All right, 8.4, energy level diagrams. Now, energy level diagrams are representations of the different subshells of an atom, in which each subshell is separated vertically, from the others in order of their increasing energy. Each orbital is represented by a short horizontal line. Orbitals within a subshell are at the same energy level and are referred to as degenerate. So orbitals within a subshell are degenerate. Electrons are represented by arrows pointing up or down, which represents the spin of an electron. Now, a key point here is that when an orbital holds two electrons, they must have opposite spins. So what that looks like is this is acceptable. This right here would be frowny face, because they both have the exact same spin. So you're never going to see that. When a subshell holds more than one unpaired electron, they must have the same spin. Now, this is effectively what an energy level diagram can look like. Each one of these lines, you're going to put 1, 2. And what we see here is energy increasing as we begin filling in all of these different spots. So, as just kind of as an explanation, or as a idea of what an energy level diagram is going to look like, that's it. Electron occupancy of these orbitals in a neon atom. So neon is an element with a total of 10 electrons. Now, those first 2 electrons are going to be put in the 1s orbital. Those next 2 electrons are going to be put in the 2s orbital, and then the next 6 are going to end up in the 2p orbital. That's effectively what you're going to see. Now, there are not going to be any electrons in a 3s orbital for neon because, well, that's where you would put the 11th and 12th electrons, but neon does not have a total of 12 electrons. Now guidelines for making your energy level diagrams. The Aufbau or building up principles, the process of filling subshells from the lowest energy upward. Hund's rule, so we've got basically 2 very important things. We're going to start from the bottom, much like pop superstar Drake. We start from the bottom, and now we're here. Hund's rule states that electrons within a given subshell remain as unpaired as possible. So if you had 2 electrons and you were putting them into the, I guess that would be the 2p orbital, you'd put 1 electron here and then another electron here. You would not, so I'm going to put smiley face here, you would not do this, 1 up, 1 down, because they're going to be paired up, and you want to keep them as unpaired as possible. All right, if there are 2 or more unpaired electrons in a given subshell, they must occupy different orbitals and must have the same electronic spin, which is what we see here. That's due to Hund's rule. So here we have a total of 3 different energy level diagrams for carbon, nitrogen, and oxygen. Carbon has a total of 6 electrons. First 2 in the 1s, the next 2 in the 2s, and the next 2 in the 2p, and they are unpaired. Nitrogen has a total of 7 electrons. 2 in the 1s, 2 in the 2s, and 3 in the 2p. All 3 of those are unpaired. Oxygen, 2 in the 1s, 2 in the 2s, and then 4 in the 2p. 2 of them are paired, the other 2 are unpaired. Now, using that, let's go ahead and make the energy diagrams for something like, or for these atoms. We've got fluorine, oxygen, and fluorine, oxygen, and boron. Fluorine has a total of 9 electrons. Oxygen has a total of 8 electrons. And boron has a total of 5 electrons. So, let's see, I'll go with fluorine, 1s, 2s, 2p. Now, one thing that's important, you could look at this as the 2px, py, 2pz. these p orbital electrons are slightly higher energy than those 2s orbital electrons. And the way that I'm going to do this is we're going to look at different, I'm going to pause it basically, and I'm going to show you boron, oxygen, and fluorine. So the first 2 electrons for all of these are going to go into that 1s orbital. The next 2 are going to the 2s orbital. And then for boron, our 5th electron goes into the 2p orbital. It doesn't matter if it's the 2px, 2py, 2pz. That 5th electron goes in the 2p orbital. Okay, so this right here is boron. Okay, now oxygen, we're going to go boom, boom. Now we have a total of 7 electrons. Now 8 electrons have been drawn. That would be the energy level diagram for oxygen. Fluorine, we're going to put 1 more electron in that 2py orbital, and done. All right, so ultimately this is, I would argue it's not extremely challenging. This is definitely with practice you get better and better at it. Whenever you're only dealing with the s and p orbitals, it's pretty simple and straightforward. But once you start dealing with the d and f orbitals, it gets a little bit hairier and it gets a little bit trickier. So starting with the 3rd, which would be the d and 4th shells, the f shells, energy levels of those subshells begin to overlap. For example, the energy of the 3D subshell is in between that of the 4s and 4p subshells. Using an orbital filling diagram to learn and remember the order in which subshells are filled, you can kind of save yourself a little bit of stress. So what this instructs you to do is list the subshells for each principal energy level, 1 line per principal level. Draw a series of diagonal arrows pointing down and left through the subshells, and the order of the arrows is the filling order of those subshells. You see that here. Here is our principal quantum number, 1 through 7. Then you say what are the subshells associated with that principal quantum number. 1s. 2, you got 2s and 2p. 3, you've got 3s, 3p, 3d. 4, you've got 4s, 4p, 4d, 4f. 5, 5p, 5d, or 5s, 5p, 5d, 5f. 6, 6s, 6p, 6d, 6f. And 7, 7s, 7p, 7d, 7f. Now, the sequence in which these orbitals are going to be filled, however, is first you're going to fill the 1s orbital, then the 2s orbital. After that, you're going to fill the 2p, then the 3s orbital. After that 3s orbital, you're going to fill the 3p, then the 4s orbital. Then you're going to, after you filled the 4s orbital, you'll fill the 3d orbital, the 4p, and the 5s orbital. Okay, then the 4d, 5p, 6s, the 4f, 5d, 6p, 7s, then the 5f, 6d, 7p, finally the 6f, 7d, and 7f. Now, we're going to do some electron configuration work in a little while, and that will make this a little bit more clear, but this whole diagram right here is something that we will be kind of utilizing to instruct our orbital filling. All right, well, I hope this helps, and practice makes perfect, and you got this.